Hey, this is Leach with Simpson Math, and in this video, we're going to be talking about set operators like the union and the intersect, and also be using Venn diagrams to kind of help us understand them a little bit. So let's get started with this question. This is question 17 on my section 2.3 for my contemporary students, if you're watching this. All right, assuming that A and B represent any two sets, let's identify the statement as either always true or not always true. So that could maybe be true in some cases, but notice this is talking about always. Always has to be true or not always true. So this says A and B, or A union B, is a subset of A. All right? Is that true or is that not always true? Tell me out with that. I'm going to draw a Venn diagram so it can help me be generic. Sometimes if you're using a specific number, you're like, well, in this case of these numbers, or these objects, it works, it's true, but we want it to be generic. So I have A and B labeled in my Venn diagram, and then A and B, A intersect B, would be this region here. So that region there, intersecting A and B, is that always going to be a subset of a subset of B? I misspoke, a subset of A. Well, for it to be a subset of A, that means it needs to be completely contained by A. Notice we're not talking about a proper subset, so it could equal, or it might not. But it needs to be completely contained, completely inside A, nothing hanging out, nothing not quite being there. And it does. In order for it to be A and B, it is all inside of A, so it is always true that that would be a subset. Notice if this was not the intersection, if it was a union, it would include this section and this section as well, and then that would not be true. They would not be a subset because of this extra part that is not inside of A. All right, let's take a look at this next one. This is just the flip. This is saying that A is a subset of A and B. So this is saying that the smaller element would be A, and all of A is inside of A and B, A intersect B. Well, let me highlight again A intersect B, which is this piece here, and is all of A inside of that blue piece? No, obviously not. A is definitely bigger, potentially bigger than A and B. You could, again, find a case where that might not be true, but in this case, and that not be true, by the way, would be if all of A is inside of B, then that would work. So you have to be careful about that. So here we have that that's not always true. All right, next. Assume that A and B represent any two sets. Identify this as being true or not. So we have here that the number of things, so this is the cardinality, which we'll investigate a little bit more in the next section in 2.4. The cardinality, the number of elements in A union B, is equal to the number of elements in A plus the number of elements in B, but minus their overlap, minus the number of elements in both. And so this is true. This is kind of setting the stage a little bit for probability. We'll see this this idea show up later. So here I'm going to go ahead and use numbers just to kind of help us out. I'm going to intentionally avoid 0 because that can kind of mess things up a little bit. So let's say there were 4 things in this piece of A, let's say 5 things here, and 6 things here. So 4 things in that part of A, 5 things in their intersection, and 6 things in that part of B, the part of B that's not in A. So this would be that the number of things in A would be 4. The number of things, if I add that to the number of, oh, I misspoke, that is not right. Let me just make sure we're clear about our givens here. So the number of things that are in A is the 4 plus the 5, so 9. The number of things that are in the B is 5 plus the 6, or 11. This right here is the A and B, and so we can see that the number of things in A and B is 5. And I want to know about the total things. Well, if I add them all up, the number of things of A union B, that's 4 plus 5 plus 6, that would equal 15. So let's just see first mathematically if this pans out what we have earlier. So on the screen, we have that the number of things in A union B should equal the number of things in A plus the number of things in B plus the number of things in their overlap, A and B. Where we just said that A is 9, B is 11, so that's 9 plus 11. Oops, I miswrote this. This should be a minus. There you go. Minus their overlap. Their overlap is 5. So we end up with 20 minus 5, or 15. So it worked for this specific case, but would it work always? Well, so what I'm going to do is I'm going to just replace this with numbers. So I'm getting a little bit more ahead of ourselves, of just kind of proving wise, but it's kind of like what we did in the last lecture with doing letters. So I'm going to replace the 4, 5, 6 with, let's just say X, Y, Z. X, Y, Z. So that would mean that the number of things in A is going to be X plus Y. The number of things in A is equal to X plus Y. Number of things in B is equal to Y plus Z. The number of things in A and B is just Y. And then I'm going to just replace this work here. We know that the number of things total is going to be X plus Y plus Z. So if I replace the number of things with A, we just said was XY, X plus Y rather. The number of things in B is Y plus Z, so plus Y plus Z. I think we might see the problem here. Do you see this double Y right here, this Y plus Y? If I don't do anything, if I don't have this extra part right here, I'm going to get X plus 2Y plus Z. So I have too many Y's. So what do we need to do? We need to subtract one of the Y's out. Lucky us, that's what the formula does. The number of things in A and B is 5, or more loosely is that Y. So now, one of these Y's can cancel to 0 because Y minus Y is 0. And so we're left with X plus Y plus Z, which is what we were looking for. So notice how I can use just not numbers, but just some letters to show that, yep, that's always going to be true. So it is. One more, and this just kind of goes along with what we're doing. We were just doing it for always. We're making a conjecture here. So the next several problems on the assignment would be something like this. So this says U are the integers 1 through 9 inclusive. X is 5, 9, and 1. Y is 9, 7, 5, and Z is 5, 3, 1. We really just need X and Y, and that's a little bit confusing because it has U. That is a capital U. That is not this U. This U is U for union. This is a capital U naming the set. They probably shouldn't have done that because that's weird. But they're using U because it's just one of the letters before X. All right. So ignore. Oh, I take it all back. I forgot. U is a universe. So that's where they're using U. U is a universe, but that U is the universe. So that's all possible numbers here. Like in the Venn diagram when we had the space outside of the circles, that's the universe. We're only dealing with the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. But do be clear that U is not that U for union. All right. So we have 5, 9, 1, and Y is 9, 7, 5. And we want to find what X union Y is. Union, remember, we're just putting drinks in a cooler. So X has the drink 5, 9, and 1. Y has the drink 9, 7, and 5. So when I look in the cooler and see what drinks are in there, 5 is in there. But 5's in both X and Y, don't care, but 5's in there. 9's in there, both X and Y wanted 9, cool. 1's in there, X just wanted it, but it goes in. 7's in there, just Y wanted it, but 7 goes in. So it's 5, 9, 1, 7. It doesn't matter whether it's least to greatest, but I probably would do least to greatest, but it is easier to write it in that order. All right, what about this next one? What about y union x? It doesn't matter, again, whether it's x union y, y union x. Order doesn't matter for those, so it's going to be the same. So we're making a conjecture. Conjecture is kind of like an educated guess from this one example, so it's not a proof. So the conjecture would be that for sets x and y, that x union y and y union x do equal each other. So that the next several questions do follow that. Here we're making conjectures instead of specific things. All right, hope that helped. I'll see you in the next one. Bye.